Welcome to Math 3163, Introduction to Abstract Algebra, also known as Modern Algebra. And this is our page. I'm going to be making a video here, and I'm going to actually post it on our front page here, so it'll be there before you know it. I just kind of want to give you guys an introduction to the course under the idea of this being an online course for this summer, which is obviously this is a higher level math course, so this is traditionally a little bit more advanced in terms of being an online course, but I'm going to do my best in being able to get you this information and stuff. So I'm going to let you know what exactly I plan on doing with you guys. So the first thing I want to do is actually go to the syllabus. You can click on the syllabus here, but I printed one out for you guys. So here it is right here. This is our syllabus. So again, my name is Dr. John R. Taylor. My office typically is in 335A, but they don't let me hang out there much these days. But so due to the COVID-19, I'm afraid my office hours will be, quote, by appointment. So shoot me an email and we'll make us a plan here. Here's my phone number for the office, but again, I won't be in the office very much, I'm afraid. Yeah. But if you leave a message, I'll get it, but it may not be the same day or whatever the case may be. Now, most important is the textbook we'll be using. We're using the Abstract Algebra by Hungerford, the 3rd edition. And this is what the textbook looks like. It's an absolutely outstanding textbook for introducing the concept of abstract algebra. This is the abstract/modern algebra. Those words are typically interchangeable. This book is absolutely very readable, because let me explain to you guys. Who signs up for a modern algebra class? This is typically your first math proof class. Who's required to take this? Well, in my class, typically I'm going to have a third of my class going to be math majors or double majors. Actually, probably about more than half are going to be majors or double majors. And then I've got about 25% of my class that's going to be minors in mathematics, folks that in the engineering department or whatever, chemistry, biology, that are going to be minoring in mathematics, and this is a course that they want to take through their minor. But the other folks that about 25% of my class is going to be folks from the math education department. They need to have this class to be able to teach effectively mathematics and understand the higher level mathematics of the material that they're teaching and stuff. So we have a broad range of different majors that are actually going to be taking this particular course, because it's your first real math proof class. So the textbook is the 3rd edition, Abstract Algebra, an Introduction by Thomas Hungerford. And this is what the book looks like. So make sure you get it. It's very readable, and it's a good book, and it's a book you gotta have. Now, here's my syllabus. And so kind of want to go through with you guys what the big deal is. So actually, to be able to get into this particular class, you should have had Calculus 2 and linear algebra. And the linear algebra aspect, that matrices that you guys have had. When I want some weird examples, matrices is a great place for weird examples. That's why it's a prerequisite for this class. The objectives here is examples and elementary properties of basic algebraic structures, especially in groups and rings. And our focus is going to be on rings, honestly. We'll look a little bit at groups because half of a ring ends up being a group. I'll talk a little bit about that. But the way the book is set up, we're going from chapter 1 through chapter 6. We're going to be focusing on rings. Okay? The course emphasizing the writing of proofs of elementary proofs. So this course also satisfies your writing intensive class that some of us science majors have to have. So that COGE writing goal that they're after and stuff like that. So that is very helpful for us folks in the math major or double majoring field and the like. Okay. How I plan on putting the grade together is 50% will be from test averages. I plan on having 3 tests. So let's go through the math. If I've got 3 tests and I'm going through 6 chapters, pretty much every 2 chapters I'm going to have a test. Chapter 1, 2, I have a test. Chapter 3, 4, I have test 2. Chapters 5 and 6, I'll have test 3. 20% is going to be from homework. And honestly, the homework is really where you master this stuff at and getting the patterns down. So the homework we'll be giving throughout the semester, and typically before each test, I will give you about 3 homework sets that have obviously parts A, B, C, D, 1, 2, 3, whatever. So there'll be 3 of those for each test. So at the end of the day, I plan on giving you about 9 or maybe 10 homework sets that you're going to have to do for the course, and that'll make up 20% of your grade. And it really will help out in that 50%. And then, of course, departmental directives, 30% of your grade must come from a cumulative final exam. And for us, that cumulative final exam is supposed to be on Wednesday, June 24th, from 3 until 5:30 p.m. And thanks to this COVID-19 and my directive, I'm going to have to come up with an online exam for you guys. And I'll be working on that throughout the 5 weeks when I get it to you. So, but also the test will also be online as well. So we're going to be talking about strategies and stuff like that, and times and stuff. Now, this class was originally designed to be from 3 until 5, Monday through Thursday. So I'm kind of creating a system to kind of focus on that particular aspect of, every day I'm going to be covering about 2 hours worth of lectures I'm going to deliver to you guys. So. The material. This course will cover chapters 1 through 6 and will be a proof course. Most of the problems will consist of you proving statements through definitions, theorems, and logic, what we call a direct proof. This course is designated as writing intensive, which means it serves 2 purposes: to learn elementary modern algebra, abstract algebra, and to learn how to write mathematics, partially satisfying the College of General Education writing goal. You'll be asked to prove algebraic statements. You'll be use a minimum of symbols in proofs. Some symbols are forbidden and written proofs for your homework. Among these symbols, the implies and subset, you got to write the word instead of the slash for divides and stuff. Is not, you write the word divides. Don't be lazy about this material. You have writing intensive. You want to write it out. But later on, the occasional use of symbols like X is an element of set A. When we get really big into this stuff, we don't have to write X as an element of A. We will be allowing you to kind of start doing a little bit of shorthand, but we want to see the word divides. We want to see by definition of, and then you got to tell me the definition of divides, definition of congruence, or whatever the case may be, because you want to make sure your proof is, dot your I's and cross your T's, and it's a perfect proof. Okay. Now, the online course policy, being this is a class that's traditionally not taught online, this is Math 3163, Introduction to Abstract Algebra, Summer 1, a 5-week summer course. So most of the students will find this material difficult in that it is typically your first math proof class. To be able to get through the material in 5 weeks, you will need to read, take notes, and from the anachronistic course videos. I plan on making videos for you guys of the material covering it. Instead of making you here at 3 o'clock every day for my video lecture and stuff like that, I'm going to make the videos and I'm going to post it. And I recommend you right at 3 o'clock get used to that systematic. I've got to go study, I got to go watch notes, I got to watch the videos, I got to take notes off of it and stuff. I'm going to make videos of me pretty much teaching you guys this material, and I'm going to be posting it and so you can, but the reason why I want to post it is so that when you look it over, you may want to watch it twice or something or other, because there's a lot of detail to this higher level math class stuff. You may want to watch it multiple times. So that's why I'm going basically doing my lecture videos, which I haven't created yet. So I'll be creating these guys just before I give them to you guys. So my goal is to make sure I post the videos at class time, which is 3 o'clock. Monday through Thursday. That's how this class was originally designed. So that's when the new videos, they'll be there probably before that, but my goal is to get them there by 3 o'clock so you can have that, expect something the same day throughout the 5 weeks and stuff. Okay. The purpose of the videos is to make so you can go back and rewatch the material. So if you need to plan, so you will need to plan to work an average of at least 3 hours per day. Remember, we're squeezing a 16-week course into 5 weeks, so you got a lot of material to cover. You got to watch the videos, you got to do the homework, you got to. It is going to be a very time-intensive class, so you can expect at least 3 hours of work per day, Monday through Thursday. Hopefully, with the weekends, you have a little bit of a break until Sunday, and then you got to get back right at it Sunday. I also plan to have WebEx Zoom meetings once or twice a week to discuss examples and problems and whatever questions you guys happen to have. So I am going to do this kind of a live WebEx, Zoom, whatever system works for us, and what I can get working at my home computer and the like. But we will have some times that we'll get together and talk, and I'll work some problems with you guys and stuff like that. But the most important thing will be those lecture videos that I plan on creating that you can watch at your leisure there. But you got to be Johnny on the spot. You cannot procrastinate with this stuff. This course will kill you, especially it's only 5 weeks, so you got to get started quickly. So as we cover 6 chapters, we'll have 3 tests. So each test will cover 2 chapters. So there it is. So Test 1 is Chapter 1 and 2. Test 2 covers Chapters 3 and 4. Test 3 covers Chapters 5 and 6. And to prepare you for the test, I'll give about 3 homework sets per test material. And that's where you learn it. And we're going to have these homework sets for you guys. You're going to do them. You're going to scan them as a single PDF file, and you're going to attach it to your Canvas page. Okay, that's kind of my plan here. Okay. Let's see here. To turn in your homework sets, you'll have to scan solutions, and most important, a single PDF file. That way it will actually link to the Canvas page, and then we'll go in there and get them graded and then get them back to you guys and stuff. So, okay. This course is an upper-level math course, typically not taken online. However, I will do my best to convey the course information in a way that you can understand and master the material. We are kind of going into new waters with this odd idea of converting everything to online courses, and you guys probably know better than I do that some classes are just better online than other classes, and higher level math classes typically is not known for being great with online. But again, I'm going to do my best to make sure you guys understand this material and give you guys something that you can hopefully follow through and master the material on. The other part of the syllabus is this. I did put a tentative schedule of what we're going to do every day in terms of the 5 weeks. So May 18th, I plan on introducing myself, which I'm kind of doing on the video, but I'm going to create a video where I'm going to be going over section 1.1. Then on May 9th, I'm going to cover section 1.2 and 1.3 with my lecture, and I'm going to go through. 25th is Memorial Day, so don't look for a video on that day. And then typically, this is what I like to do. Once I finish up Chapter 2, I'm ready to give you your first test. But instead of giving you a test right then and there, I'll give you a weekend to study, and then we'll have the test. So I'll review a little bit for that test and do a little review video and some questions you guys maybe send me through email or whatever the case may be, and the information I get from your WebEx conversations or whatever. And then we move on, Chapter 3.2, 3.1, 3.2, so forth, Test 2. Give a little bit of space, but can't stop. I'll cover 5 and 5.1 and 5.2. Then we'll have our Test 2. And then keep on going and for Chapter 5 and 6. Then we'll have the review for Test 3 and then Test 3. Then I plan on having some type of a review, talk about what I expect to put on the final exam. And then on June 24th, from 3 until 5:30, we're going to have the final exam. Now remember, this class was originally designed to be between 3 and 5. But with it going online, of course, they don't actually put times and stuff like that on the course anymore. But so I will work with you if you can't make the classic 3 to 5 time slot or whatever the case may be, especially when it comes to taking the test and stuff. But do try to plan your 5-week summer schedule around this course so you are there. And don't forget, you got to make sure that you've got about at least 3 hours a day to be able to work this material. Let me come over here and show you the Canvas page. Again, I'm going to post this video right at the front. And typically for me, here's the syllabus. You can also get a copy of all the stuff that we just went over here. But typically for me, I put everything in modules. So even though this course is just starting as we go along, I've got a module blank where I'm going to put my lecture videos, and I'll even put this one as my first lecture video, even though I'm not really lecturing. I'll have a place for your homework, homework number 1 and when it's due and stuff. And then I'm also going to do a special video of solutions to the homework sets that I've got some old videos that I've had. I may put some of those in there to help you out as well, and make some new ones, of course. but this is kind of the template of how it's going to go. So you watch the lectures, take notes off of it. That's really important. There's no, it's not like calculus where I give you a guided notes or anything like that. This is classic paper, pencil. When I write something down, you should write it down, write down the proofs, go back over it, and there is a lot of memorization for this course and stuff. And so you'll actually get to know the theorem numbers out of the book. Theorem 1.2 is very famous. You'll get to know and quote theorem 1.2 within your proofs and stuff like that. So, but again, it is 5 weeks. So with a traditional 5-week course, when I teach this class in 16 weeks, I usually have you have that soak-in time where you have time to kind of mull it over, and I don't tell you all the exact patterns and stuff. I want you to kind of develop the patterns on your own. But with 5 weeks, I don't have time for you to catch a pattern. I'm going to have to explain what the pattern is. So I'm going to cliff noting the material to be able to make sure that you understand and see what's going on and what the structure is. That's the key, and that's your classic math. You're looking for patterns and structures. So welcome to Abstract Algebra, Math 3163, and I look forward to working with you guys. Class starts on Monday, but I'll open up this page and the Canvas page actually this weekend. So I'll see you then.